Hello, everyone. We are text2mc, the student-led project trying to implement generative AI in Minecraft. So text2mc, of course, means text to Minecraft. We're a student-led project, so we have a sponsor, but he really only checks in with us and provides us updates and general guidelines on the direction of our project.
So what are we trying to do? Well, we've seen generative AI start to accrue all these new applications, and we've seen it in one dimension with large language models, and we've seen it in two dimensions with image generation. So we're trying to take that to three dimensions in Minecraft. We as humans have the ability to look at a build in Minecraft and tell certain things about it, tell different builds from each other. So we wanted to use different machine learning techniques to create an AI model that can do some of those same things. And this project is inspired by WorldGAN, which is a paper that implemented biome generation, but not player-made builds. And as you can see in the image, the real inspiration and proof of concept for our project was the village biome that WorldGAN was able to generate. You can see it was able to make some very rudimentary buildings as well as the terrain.
So our project Text to Minecraft is made up of a bunch of different components that link together, and all of us communicated and collaborated together, which shows the number of bullet points that we have for each person here.
So the first component of our data processor is called world to vector. We use the web scraper to accrue a large data set of Minecraft builds from the website Planet Minecraft, and many of them were downloaded as proprietary Minecraft world folders, which contain the entire Minecraft world that the build is within. So we need to search the entire world to find the player-made build and extract it. This is, of course, computationally expensive and also takes a very long time. So we needed to make numerous optimizations to this process. Two of the most impactful were firstly locating a native Minecraft tag called inhabited time, which shows how long a player spent in a particular chunk. So if that number is below a certain threshold, we don't search the chunk at all. Additionally, once locating the build, different versions of Minecraft have different Y levels for the surface. So we also implemented version checking to find the surface based on the version of the world.
Once we found the build itself, we ran into some issues regarding multiple builds within a single world. So we used something called dbScan, which allows us to separate out each of the different builds into their own sections, and we process them separately. Once we've done that, we then can save the build into a file called schematic, which just holds the data just for that build. However, when we first started, we didn't realize that there were extra metadata associated with the blocks, something called block data, which handles things such as like the direction that they face, if they're connected, or if the water's flowing. You can see that clearly with the stairs, the buttons, and the doors all being broken, and the fence is not connected. However, once we added that, we ended up with the full build, which is on the right, which you can see with the house that's completely connected.
We had a part of our program called vector to world, which just reverses the process from world to vector. So we have a file that the computer can read, that our model can read, and then we just convert that to a Minecraft build.
If you look at the images on this slide, even though the individual blocks in the second build are totally different from the blocks in the first, both builds are recognizably similar. However, a machine learning model doesn't have this human perception of comprehensive similarity. So that's why we need block embeddings, which are a way of representing Minecraft blocks in a way that the machine learning model can understand. Embeddings are fixed dimension vectors, which by some algorithm capture both the identity and the semantic meaning of a block. Block2Vec is based on a 3D implementation of skip-gram model architecture, which is an algorithm for natural language processing. Basically, the embeddings model tries to predict a target block from the context blocks which surround it, and after we've passed our entire data set through the model's internal weights become the embeddings.
So now that we have the full process to convert from our downloaded data set to a usable AI data point, we need the actual generative model itself. So the simplest form of generative modeling is called a variational autoencoder. So essentially it is trying to reconstruct the input and have that as the output. But there is a bottleneck in the middle of the model, which means essentially it has to find a smaller dimensioned representation of the build itself. So You can see in the latent space, which is the compressed representation, nearby data points are similar, and conversely, far away data points are dissimilar. So the way that this is generative is that you can take two different Minecraft builds, squeeze it down into this lower dimensional so-called latent space, and then calculate a line between those 2 points and send those samples of points on that line through the right half of the model to generate a novel build.
So the purpose of the predictor is to use that latent space to generate the new build. So in the picture on the left, you can see there's two different types of chairs, a chair with arms and a chair without. And we start with the chair with arms, and as we transition on that line, we can see the new generations. And it's more visual in the Minecraft implementation. So we start off with an island, and it's turning into a mansion, and every single frame in the GIF that you can see is a new build that the model generates.
We rendered all of our builds using Blender and Python. We automated the process to make sure that we can get very quick feedback on what the builds that the AI model makes.
Testing this model is not a completely straightforward task, but we've employed different methods to help us measure the quality. First, we use dataset splitting to make sure our model loss is accurate, and this furthermore just makes sure that we don't get an artificially high notion of performance due to the model just memorizing the data rather than learning. We also measured our model performance with a variety of different literature-backed methods like reconstruction loss, binary cross entropy, Kullback live blur, divergence, and everything else you see on that bottom bullet. Visually, we can also compare text2mc to WorldGAN, and as you can see by the image, text2mc shows considerable proficiency in generating terrain.
So for presenting our information for Text Minecraft, we created a website with React and Bootstrap to showcase our project as an infographic.
So we have the website here pulled up, and it's very user-friendly. You can just pick two example builds from the data set, and then it generates the interpolations between those builds. So, for example, these two builds generate something, and the overarching goal of this project is to create the first foundation model for the Stable Diffusion method, which eventually means you can add textual conditioning to your generation. So, for example, say I want a mansion with very colorful blocks or bricks or something, and then it'll make something like that. But to do that first, you need a smaller representation, which is that compressed representation I was saying earlier.
So why does our project matter? Well, the space of generative AI in 3 dimensions has been rather underexplored over the past several years. We hope that text2mc can serve as a starting point to future generative AI projects in 3 dimensions, both in and out of Minecraft. Also, by using Minecraft, one of the most popular games that are out there, we hope to spark curiosity in generative AI in a larger audience, and the younger audience that plays Minecraft might be interested in getting into STEM topics because of our project as well. Finally, you have the full text-to-MC. You can see how all of our building blocks work together to create the whole generative model.